Okay. Yes. So today's our topic is stack ADT. Okay. Stack ADT. ADT stands for abstract. Stands for abstract. Okay. Data types. Okay. It stands for abstract data types. So what does it mean? ADT means what? ADT is it defines all the operations of the stack. So stack has the operation, right? It is a linear data structure. Data structure stores the collections of values, right? Collections of values. So the first operation will be how to store data. So in the stack, the first operation is called as push operation, right? To store the data, we use push function operation, or we can say function. Push some data item, some data. So we can store any data, either integer, float, double, string, any data we can insert into the stack. So stack is like a data structure, memory area. It is a memory area where we insert data, okay, by using this function. Second operation is pop. Pop means to remove the data. So all the operation, ADT defines all the operations theoretically. That is the difference. Okay, theoretically and practically. Practically means we need to write the code for that. Okay, we should implement this function either in Python programming code or C++ or Java, any programming language code. That is called implementation of this function. Okay, or definition by using code. So we can define the function in two ways, one theoretically and practically. Theoretically, it defines, ADT means it theoretically defines all the functions. What are the operations are there? Their logic they explain in theoretically. So by seeing the ADT, we can implement the code. Okay. Then next week we will go for the next topic. We will go for stack implementation. There we will see the same. Okay, same definition, theoretical definition, and we will try to implement in the Python code, Python programming code. Okay. So it has how many functions? 5 operations are there. Pop, then is full. Is full means it return Boolean value, true or false. Is the stack is full? Full means, for example, a stack has some capacity. Okay, it can store only maximum 5 elements. For ABCD, some for example like this. Okay, this is here capacity. 5 elements maximum it can store. Okay, if the full stack is full. Okay, then next I cannot insert next element. For example, F4, I cannot able to insert, right, this value. So it will say that this function will say that your stack is full, you cannot able to insert next element. So this function will be used inside the push function. Before insert the data, before push the data, first it will verify this function will call this function, okay, to verify whether the stack is full or not. If it is full, it will write this function will return true, so that we cannot insert the data. Okay, for example, your stack is available, some space is available. This function will return what? False. Push function will call this function and it will return false. Then what happened? We can insert data. This function can execute. This function can insert data to the stack. Okay. Now, fourth function is empty. Is empty. This function, okay, check whether the stack is empty or not. So when your stack is empty, when you initially create the stack object, first when you create the stack object by mentioning the capacity or size. So for example, I want to create the stack with the capacity of 5. So it will create 5 blocks or 10. So 10 blocks. Okay, it will create. So now this time stack is empty. We can say that stack is empty. And second condition, when the stack is empty, for example, some data are there. Okay, you perform pop operation. First time you perform pop operation, first you call pop function, remove this element. Second time you call the pop function, remove this element. Like that, if you call the pop function again and again, all the data will be removed and the stack will become empty. So stack, the two conditions, the stack is empty, okay, when your stack has no data. Initially stack object is created, null. Okay, that time this function will return true, or second time when no data is there. Okay, for example, next time if I call the pop function, what happened? There is no data. How can we remove the data, right? So this time this function, so pop function first before performing deletion, right? First it check the stack is empty or not. If the stack is empty, this function will be unsuccess, right? It will return false. Okay. So for example, there is a data, one data is there. So first it check, okay, that stack is not empty. So the deletion can be happen. So 10 will be deleted. Okay. So these are the functions. First push function is used to insert data into the stack. Pop function is used to remove data from the stack. So these functions perform one. So for push function insert one data at a time. We cannot insert multiple data at a time. Okay. So like that, first 10, then first call push of 10. It will insert 10. Then again we call the same function again 50. It will insert here. Like that, if you have any call multiple times, and it will data will be added to the stack. Again, when you call the pop function, we know stack follow which mechanism? LIFO mechanism, right? Last in, first out. So first when you call this pop function, this data will be removed. 50 will be removed. Okay. Second time again when you call this function, 40 will be removed, right? Then 30, like that it will remove. We cannot, by using pop function directly, cannot delete 10 or 50. So this mechanism is it follow last in, first out. Okay. Okay. Next this is the function. Another function is called as peak function, or you can say get top. So when you call this function, what happens? It will return the topmost element. Okay, it will display so in topmost 50 is there, but it will not remove. That is the difference between the peak function and pop function. Pop function when you call, it will return 50 and remove. At that time it will remove the value from the stack. But when you call this function, it will just fetch the value. It just fetch the value of the topmost value. Topmost value it will fetch and display. This is the topmost value. That is the 5 operation. These are the 5 operation of the stack, and it is defined by the ADT. How it defines, we'll see. First we'll discuss about the push function. In detail we'll discuss the steps, how the push function executes. Push of data, a step by step procedure. Nothing but algorithm. Algorithm means what? A step by step procedure, right? How the program executes. A step by step procedure. Okay. So first step is what? When you perform push function, for example, you are inserting some data, push of some 20. So directly the data will not be added. First step what it does, it check. This is a stack, right? This is a stack. Okay. So first it check. It maintain a variable called top. When the stack is empty, the top variable equal to -1. Okay. And same, just like an array, it has the index. Every block has the identify with the index. Okay. For example, 5 is the capacity. Size equal to 5, or you can say capacity or size equal to 5. Okay. So maximum it can take up to 5 elements. If you mention 50, size equal to 50, then it will take you can maximum 50 elements. Okay. Okay. So first step 1, directly it will not insert. For example, I want to insert 20. For example, I want to insert 20. So directly it will not insert. First it will check whether the stack is full or not. If the stack is full, this push operation will not work, because maximum it. Okay. So first it will check whether the stack is empty or not. Whether the stack is empty or not. Sorry, full or not. Full. Check whether the stack is full or not. So as we say, the stack is not full. So but this function, to check whether the stack is full or not, it will call internally, it will call is full function. It will call internally which function? Is full. Okay. It will take, this function will take the help of is full function to verify this function will give you the result that yes, the stack is full or stack is not full. So this function internally called is full. Push function will call internally is full function to verify whether the stack is full or not. As we see now, the stack is empty, no data is there. So now that we can insert the data. So step 2, if stack is full, what happened? We cannot insert data. For example, stack has some data, all the data is out there, all the stuff. Okay, there is no space. So that means whether the stack is full, stack is full. In this case, stack is full, right? So second time was second step. If the stack is full, for example, consider the stack is full. What happened? We cannot. So if the stack is full, program exit and return stack overflow. Overflow means the stack is this condition is called stack overflow. If the stack is full and we try to insert the data 20, okay, for example, the 20 is there, we can insert duplicate values also. For example, I have to insert 60. We cannot able to insert because the stack is full. In this case, the stack is full. So what happened? Remaining 3. So total 5 steps are there in this. Okay, but here only it will stop. Remaining 3, 4, 5 steps will not execute. Okay, clear? Okay. So next step 3. Okay, consider stack is not full. If the stack is not full, then second step will return false. So second step will not execute. Remaining 3, 4, 5 will be executed. For example, there is no values. Okay, either stack is totally empty or some values are there. I have to insert other values. 60 I have to insert. For example, 2 values are there. Okay, I have to insert value. So what happened? Step 3. If stack is not empty. Okay, if stack is not empty. Okay, increment top variable value. Okay, so when the stack is empty, I told you in the previous class, when the stack is empty, it maintains a variable called top, right? It maintains a variable called top. Okay, from this is called top end. From here data is inserted, this end the data is deleted. From the same end data is inserted, deleted. So when that stack is empty, that means stack top equal to -1. Okay, -1. For example, stack is empty. Okay, I want to insert a value 60. I want to insert a value 60 to this stack. So what happened? First it will increment the top value. Top variable value it will increment by 1. So top will become what? Top will become -1 plus 1. So top will be equal to 0. Top will be equal to 0. So first it will increment top will equal to 0. 0 means it will point, top will point here. Top will point here. So step 3, it will increment a top variable so that it will point to the stack. So if the stack is empty, top equal to -1, that means it is not pointing to the stack. So what happened? Increment a top variable, then step 4. Then step 4. Add data to the stack. Now step 4, what we will do? Whatever the data we are inserting, for example, push up 60, right? We are inserting 60. So this 60 will be added to the stack at index 0. Okay. Next step 5, return success. Success means what? The data is successfully inserted. So push function can return success or unsuccess. Unsuccess means step 2. If the stack is full, it cannot able to insert the data. That is called unsuccess. The operation will be unsuccess. Okay. Now this is about the push function. For example, take another example, another data. I want to insert another data, push up some 40. I want to insert next value. Now your top variable is at this index. So first check whether the same process, check whether the stack is empty or not. Check whether the stack is full No, stack has only one data is there, remaining empty is there. So stack is not full. This step executed. Second step, stack is not full. So second step will not execute, right? Second step will not execute. Only this will execute when the stack is full and program will exit. Your okay, push function will exit here only. Okay, step 3. If the stack is not empty, yes, not empty. Increment the top variable. Now increment the top variable by 1. So 0 plus 1, 1. So top is now pointing here. Step 3 is executed. Okay, clear? Now step 4. Add data to the stack. Okay, add data to the stack. What is the data? Now we are inserting 40. So 40 will be inserted here. Clear? 40 will be inserted. This system all completed. Return success. Then it will send the message. Return success means what? Like it will print the message like data is inserted. Okay, data 40 is inserted. This is the success message you will get. Okay, so when we see this logic, okay, in Python code, then you will understand more clearly this. Okay, so understood this logic, insertion, how the push operation performs. Okay, like this we can insert all the data to the stack. Okay, okay, until it reaches the size. We can insert one by one. Top variable will be incremented. Okay, next we will discuss about second function, pop function. Any doubt in this push function? No, right? So next we'll go for the second function of stack ADT. Second function we'll discuss. Okay, pop. Okay, second one is pop. So it follows what mechanism? LIFO mechanism. Okay, last in first out. This function follows LIFO principle. LIFO, last in first out principle. Okay, so if you want to, for example, two data are there. So if you want to delete the data, okay, so topmost element will be deleted, 40 will be deleted. Okay, because last in first out, we inserted 40 last, first inserted 60, then 40, right? So 40 will be deleted. Okay, for in this example. Okay, now here also some we'll discuss step by step procedure, just like push function, step by step procedure. What is the step by step procedure? Okay, first one, step 1. Okay, just like push function, it will check the check whether the stack is empty or not. If the stack is empty, for example, check stack is empty. Consider stack has no data. Stack has empty. So this function will be unsuccess, right? It will cannot able to delete the data, right? So that time this function will be failed. Okay. So but in this case we have data, right? So first check whether the stack is empty. So push function always check stack is full or not. If the stack is full, we cannot insert. Okay, this function reverse. If the stack is empty, this operation will fail. Pop will be fail, right? Okay. So next step 2. In case, just like previous function, if the stack is empty, what happened? Return unsuccess, right? Return -1. -1 nothing but negative value, nothing but unsuccess. Return, otherwise you can say stack underflow. -1 or underflow. Underflow means, I told you, right? Underflow means if you try to delete an element but the stack is empty, that condition is called stack underflow. Okay, if you try, and stack overflow means you want to add an element but there is no space in the stack is full, that condition is called stack overflow. This is important, okay, for multiple choice question. Sometimes this type of questions asked. Okay, next step 3. Okay, if the stack is empty, we cannot able to delete. So step 2, from step 2 here only our program will exit, our push function will exit here. Sorry, pop will exit. Now step 3. Step 3, if stack is not empty, in this case, in this example, stack is not empty, some data is there, so we can perform pop operation. We can perform pop operation. Okay. So what? How? First it will what? Decrement the top variable value. Top variable value. Okay. Top variable value. Okay. So for example, so here. So now when this will deleted, what happened? Top will not point to here. Now top will point to here. We try to decrement the value. Clear? So now stack has only one data. Stack has only one data 40 because it is deleted. Okay, we will decrement the top variable. So when it is not pointing means the data is okay. So next step for 4. Step 4. Okay. What it will do, step 4, just display the data. 60 is deleted. Okay. The data is deleted. It will display the data. Data is deleted. Okay. Display the message that particular data 60 is deleted. Okay. Then step 5, success. Okay. Similar to push function. Okay. Check whether the stack is empty. If it is empty, we cannot able to delete the data. If the data stack is not empty, then only we can perform the pop operation. Pop means deletion. Okay. If the stack is empty. Okay. Here only step 2. Only we close the pop function. Here only. Okay. If it is not empty like this. Okay. So what first will decrement the top variable. Okay. First it is pointing to here, right? Here. For example, your stack has like that, some values are there. So your top will point to last element, always point to here. Okay. Then when you perform the pop operation, the first will move the top to decrement the top variable, value. Okay. Then delete that value. Then perform the delete operation. Then return success. Yeah, successfully we deleted the data. Okay. Next. Third function. Okay, is full. This function tries to verify whether the stack is full or not. How it verifies? For example, this stack you see has another space is there, right? Another space is there. So I can insert another element, for example 50. Your top, when we insert the data, top variable will be incremented, right? So now the top is pointing here. So what is the index? 0, 1, 2, 3, 4 maximum. So 5 size means 0 to 4. Okay. How can this function verify? It verify by using the condition if top equal to, not assignment operator, equal to. This is called assignment. This is called equal to. It verifies. Okay. Equal to size minus 1. What is size value? 5. 5 minus 1 means 4. And your top value is also here, in this case 4. Right? Both are true means it will return what? True. Return true means return 1. Yes, stack is full. Okay. For example, your stack has only 3 elements. Now you say top is what? 2. Top equal to what? 2. 2 is equal to 4. Size minus 1, 4. No, right? It returned false. That means stack is not full. We can insert data. So push function uses this function. Inside the push function will define is full function. First we'll verify whether the stack is full or not. Okay. So here in this case the stack is not full. So when the top variable value is equal to the size of your stack. Size means okay 1, 2, 3, 4, 5. But indexes, right? We are using here indexes. So 1, 2, 3, 4. Okay. Then it will return true and we say that stack is full. So this function will return true. That is okay. So this function return true when stack is full. Stack is full. Okay, so this is the stack is, for example, this name the stack as S. The stack S is full, S1 or S2. Okay, stack is full. Return true if the when the stack is full, or otherwise false. So it return Boolean values. Boolean value means either true or false, right? There are two kinds of Boolean values are there, right? True and false. Either it can return true or false. This function can return true or false. When the stack is full, it will return true, and if the false, it will return false. So the logic is this one. This is the logic. Only one line of logic. If the top equal to size minus 1, if this condition satisfies, if the condition is true, then it return true. Otherwise false. Okay.